class models an entity. Acts as what we might call a blueprint from which we can then create specific objects, specific instances. Okay, objects are instantiated from the class. Okay, class defines the structure. It defines what type of variables, what type of characteristics and behavior methods that each object will have. So the class is code, but that code is only instantiated, it's only realized when we create the object. So class is the generic entity, like the student, and then we can create student objects, one for each one of you, and then give you all unique attributes, like you've all got a unique ID, you've all got a unique name, okay? And then you probably all have common behavior. You can all do certain things in common, so we can also model that in the class, and then allow you to call that behavior, to enact that behavior, call the methods to then operate on your unique data. Okay, so here's an illustration of that. We just talked about the student. Here's another example. So here we're going to talk about houses, talking about blueprints for house architecture. I thought that might be a useful illustration here. So on the left-hand side, we've got a image of a blueprint. You know, like architects will draw up, won't they? They'll map out all the rooms of a house, where the exits are, how many windows are going to go in. They'll do a floor by floor plan, you know, they'll do a scale, and they'll do the dimensions and everything. They'll map it all out before they actually give it to the builders to then build the house. Okay, so it's planned out well in advance, and then the builders will build it to that specification. Okay, so that's where on the right hand side, from that detailed plan, blueprint, we then build, metaphorically, the objects, in this case the house. We build each house from that blueprint. Now, I mean, each house could be made to the same structure in terms of its size, its build type, roof style, window style, etc., etc. But even then, even though they look the same on the outside, they will at least have a unique address. Okay? And even then, there might be certain customizations. I can see here different colors for things. So they might even though they're the same size, they might have a different outside color to them. Okay, so we might model that as well in our programming. All right, so that's what we're trying to convey. Okay, I appreciate this is still quite, it could be quite abstract because it's an idea thus far. We haven't yet come to code it, but that is the idea that we're trying to impart here. And the two parts of a class, as we said, are the variables, the data. So variables, you know, you remember you've got your data type and you've got your variable name. So the difference is you just declare them within a class, and they act as the characteristics for objects of that class. And likewise, we've defined methods before as well. We did that last week. So this time we just declare them in the context of a class, and they act as the behavior for each object of that class, if they're dynamic methods, that is.